Okay, let's
I could be like, do you believe in Santa?
go live.
I better leave.
Oh, that's fun. Hi, here's what is this? Day 11. Yeah, day 10 kicked my butt. This one, the second part of this, I completely went down some wrong solution. I did eventually figure it out the next day. I came back and I used what's called memoization. It's basically like keeping a running cache of your calculations as you like recursively go through answers. But the key for memoization is you got to start from the top down. So when we got these like lists, what we need to do is start at 22 and then say, give me a path for 22. And every time we solved one for, give me a path for the index at 22. And every time you solved an index, you would store it and say, oh, I've already solved this index. So that reduced the time it took to solve it by a huge amount. So yesterday I was getting I was running it and it was like consuming like 20 gigs of memory. But when I figured it out this way, it only took 2 milliseconds. It's probably I guess, an indication of where I need to work on as a developer. I vaguely knew about memoization. I remember learning about it as like a solution for figuring out the Fibonacci sequence. What's the Fibonacci sequence for, an index of 50? Instead of starting from the bottom and counting up, you start from the top, count down, and then keep a store of, each number you solve. So instead of having a branching path, it's, a lot simpler. All right, day 11. So I guess what we're doing in the story is we've hacked into the airplane for whatever reason. I guess we're like some sort of weird person that can't keep their hands off electronics. Then when we hacked into it, we found out that there's some weather storm. And we need more information on the storm, but I guess our tablet or something died. So yesterday's was figuring out how to power up our tablet by plugging in, what was it, like 10,000 adapters? So I don't know, day 11, I'm guessing it's probably going to say something like, oh my gosh, you ran into a storm. Somehow figure out how to get out of it. We've done opcode stuff. We've done the memoization stuff. We haven't really done anything in paths. Maybe that's what we might have to worry about. Maybe we have to figure out a way to calculate a path around this weather storm. That's going to be my guess for what we're going to see. You come across a storm, calculate a path around it on a 2D grid, something like that. Hopefully this one doesn't take me 2 hours. Ideally, I would like to go to bed. All right, here we go. You're playing lands with plenty of time to spare. Final leg of your journey is a ferry. Oh, I guess we don't have a tropical storm. Modeling the process people use to choose or abandon their seat in the waiting area. You're pretty much sure you can predict the best place to sit. The seat layout fits on a grid. Each position is either floor, an empty seat, or an occupied seat. For example, layout is like this, which looks like all empty seats or floor. Now you just need to model the people who will be arriving shortly. Fortunately, people are entirely predictable. All decisions are based on the number of occupied seats adjacent to a given seat. The following rules are applied. If a seat is empty and there are no occupied seats adjacent to it, the seat becomes occupied. If a seat is occupied and 4 more seats adjacent to it are also occupied, the seat becomes empty. Oh, so they all change all at once? Floor never changes, seats don't move, and nobody sits on the floor. After one round of these rules, every seat in the example layout becomes occupied. So let's see. If a seat is empty and there are no occupied seats adjacent to it, it becomes occupied. So I guess that only applies to the current state, because all of these are unoccupied, so they basically all get filled up. But it's not, this one gets occupied and this one doesn't because this one was. It's all one state at one time. If there's 6 around, the seats with 4 more occupied adjacent seats become empty again. 4 more occupied adjacent seats. Up, down, left, right. Ooh, or diagonal from the seat. So we have to figure out diagonal positions. Okay. And our second rule was if a seat is occupied and 4 more seats adjacent to it are also occupied, seat becomes empty. So this one, only 2 are adjacent. So this one stays. This one, 3 are adjacent. But this one, 1, 2, 3, 4, 5, 6 are adjacent. This process continues for 3 more rounds. At this point, something interesting happens. The chaos stabilizes, and further application of these rules causes no seats to change state. Once people stop moving around, you count 37 occupied seats. Okay, so we have to apply these rules to each state. Again, like usual, what does our puzzle input look like? Okay. Let's grab this test input. All right, we're gonna parse this into, let's say, 2x2 grid. So we can say we'll say seats equals new int with, we'll do x and y. So x is going to be the length of the first line. Can apply, okay. Be a list, okay. The length of the first line, and then y is going to be the number of lines. Right? All right, so there's our seats. So we need to say something like calculate next seats. We'll give it current seats. So we say first we need a new temporary set. So new seats equals a new integer array. How do we get the x and y length of this thing? Total number of elements in all dimensions. Number of ranks, number of dimensions. Ooh, maybe I shouldn't have done this. How about this? We'll do a single rank. And we'll fill it like this. Oh, you know, we in our parsing we we actually need to fill our seats. Line 0 length, and we need another iterator for our y dimension. And we're going to say, let's see, seats at I modulus line 0 length plus, ouch. No. How do I normally do this? I'll do this. I got this backwards. This should be the y field times, or the x field times the y field. And then seats of I equals lines. To get our x field, it's going to be y modulus the length of our y field. Am I making this too complicated? I already think I am. And then inside of that, we want a single character. Oh, this should be a character array. We want a single character at I divided by the length. Right? So let's take a look at that real quick. So our seats. So we should be looking at line 1 first. No? Oh, I mixed up this one. This should be, the Y portion is here, the X portion is here. Seats L dot LL L dot, yeah, okay. We're good there. All right, so in our calculator thing, we need to create a new field. And luckily, since we're doing that combined dimensions thing, we could just say current seats.length. Nice. All right. And then actually, we probably need to store this. Okay, so Y length is this guy, lines.count. Xlang is this guy. So down here we can do this iterator again. And then from here, once we get to each one, we need to count the count to the left, count above, count below, count diagonal. So what is that going to look like? It's going to be our adjacencies. We want to count the number occupied. So directly to the left is going to be current seats I minus 1. I guess we want to check if we're on the far left or on the far right. So if I equals I modulus, or if we're on the x length, no. Yes. If we're on x position 0, then we don't do left. If we are anywhere else, we can do left. So num occupied equals new seats, I minus 1, or no, current seats, I minus 1 equals pounds. If that's true, add 1, otherwise don't add nothing. If we are on the far right, which would be xlang, then it would be seats plus 1. Alright, that's left and right. Let's get top and bottom. So to make sure that we're not at the very top, we do, what is it? I divided by yling. If this equals zero, when would it be 0? It would be I minus I modulus xlang, right? So if we had a 10 by 10 square of 100, you know, x length 10, y length 10, and if we are at position 5, we would want 5 minus 5 modulus 10, we would get 0. If we're at position 11, we'd get 10. Now that's, what am I doing here? Yeah, that's right. Throw in this just in case. All right, so we need to go up, we need to subtract 1 y length. Right, so if we're on a 10 by 10, we're at 5. The next one directly below would be at 15. So to go from 15 to 5, we would subtract the y length, which is 10. Num occupied. Right, we go 1 down. We want we want to make sure we're not at the very bottom, which would be, is that right? Our very bottom would be, oh my gosh. Oh, this is dumb. We really just need to make sure that we're not, if we're less than length times y length, which I guess is just current seeds.length. If I plus xling is less than current seats.length, then we have one row below us. All right, so that would be, oh, this should be x length to go below. All right. Now, this is up, down, left, right. Diagonal, we need both. You know, this might be simpler if we just do this. I minus 1. If I minus 1 is greater than 0, then we can do this thing. If I plus 1, ooh, actually we should do that one. And this last one, I plus y length, yeah, that works out too. So for diagonal left and up, this is left, this is right, this is up, this is down. So we want left and up. I guess we should save these calculations. Let's see, can left equals this. Can left. Can right equals this. Yeah, I'm definitely making this a lot more complicated than it needs to be, but Oh, well. I'm already in it. What is this? Can up? Can up. And down. And then 4 diagonals. If can left and can up. Then we will add left. Let's see, we want to check if left and up, so y minus 1 minus, how do we go up? X length. And then if we can go left and down, it's y minus 1 plus x length. And can right and can up, which would be up is, yeah, minus 1, and then going down, or no, going to the right is plus 1, I plus 1, and then going up is minus x length. All right, and then one more, and down equals plus x length. So if num occupied is greater than 0, no wait, what was our rules? We got into this already for a while. Let's see. If a seat is empty and there are no occupied seats adjacent to it, it becomes occupied. If num occupied equals 0, then our new seat at position I equals 0. No, equals seat is empty and there are no occupied, it becomes occupied. All right. I guess we should also check if current seats I is a floor, then the new seat will still stay a floor. If the seat is occupied and 4 more seats adjacent to it are occupied, if this is greater than or equal to 4, then the new seat becomes empty. Otherwise, the new seat is the same as the current seat. All right, when we're done with this, we'll return new seats. Oh, and we also need to make sure if our state has changed. And that's going to be if one of these guys it's true. All right. We'll return new seats. Let's change it, state change to false. Okay, that makes it happy. So down here, we'll say, I guess I can just make this a reference. There you go. That makes that easier. We'll start with state changed equals false. And what we need to do, how many seats end up occupied? While state change equals false. Seats equals calculate new seats. We'll give it seats and a reference to our state change. When we're done, we will count the ones that are occupied and return that. Index was out of range, so our count wasn't exactly correct. What are we at right now? We're at 10. And we have a 10 by 10. So we're saying can left and can up are true. And we're at position 10, which should not say can up. No, you can go up. Because we would have something like this. Position 10 would directly be below 0. Oh, that's right. So it should have been false for can left and true for can up. So can left equals, oh, okay. Yeah, that was dumb. I don't know why I changed this. So it should be I minus I ampersand its length equals 0, right? So we would have got 10 minus 10 modulus 10. That's not 0. This is 0. Oh, why am I subtracting I? It's just I modulus x length. And it's not equal to 0. Can right should be I modulus x length is less than x length, right? Because if we're at position, position 9, we would have should this be, what am I doing here? Can write I modulus 9 modulus 10. Let's see, 9 modulus 10 minus 1. Okay. And can up is, I think I have that. Okay, let's see. Can right and can down for, what are we at? Position 89. We want to go one to the right and one down. I guess can right, we can. Oh, what am I doing here? What are we at? 89? Why 89? That's so weird. Oh. Length minus 1. $100. Oh. Right. 71. 37 occupied seats. So let's help this out a bit and print. Let's add a bit of debugging. All right, so we'll iterate through our seats. If we're at the leftmost column, we'll throw on a line break. Otherwise, we will write our character. All right, so our starting list looks like this, right? Yes. All right, so the next one. Whoops. You tell me this. Oh, wait. This always needs to be true. Change this to false. Okay. Let's get rid of that print. Ooh, that is definitely spinning. It's telling me that you're changing states every time? After a second round, this process continues for 3 more rounds, so it should have stopped at 3 rounds. Causes no seats to change state. Oh, you know what? We need to... We also need to check if we're not already if we're not actually changing it to the exact same thing. So if the current seat is not already occupied, then change it to what it is. And if you're not already unoccupied, then change you. All right, 33. The answer is 37. Okay, so let's print our seats. And see what's going on here. Okay. How about you pause for a second and let me look at the seats. So we go from here to here. Let's compare this with our guy over here. So this is step 1, this is step 2, which does not look to be correct. So a weird thing happened over here. This one went to empty when it should have been occupied. If a seat is empty and there are no occupied seats, if the seat is occupied and 4 more seats are adjacent to it, then it becomes empty. Okay, so we're not reading the rules, right? So if it has to be occupied, and this one has to be empty for this rule to apply. It gave me the same answer. Why did this guy go to empty? It should have counted 4 more adjacent becomes empty. So let's see, which one was wrong? Let's see, first row is correct. Second row, it's wrong at position 10, 11, 12. So let's get to 12 and then see what's going on. All right, 12. So 12 should say, this should be us at 12. So it should count 1, 2, 3, 4. You should have exactly, no, 5. And all of these can left, can right should all be true. Can left is true, can right true, can up true, can down true. So it should start, it should count where were we? 10, 11, 12. So it should count left, up, right, down. So these should all be counted. Let's see. Num occupied 0. So it said left was not 1. So what is 11? 11 is L. What? Why are these all empty? Oh, because we're on the wrong iteration. All right, let's. All right, iteration number 3. Let's get to 12. All right, so we're on 12. All the cans are true. Num occupied, so 1 on the left, 1 on the right, 1 up, 1 down, and it should be 1 more to the upright. Yep, so they are all correct. So the current seat is occupied. So it should go to empty. Num occupied is greater than or equal to 4. Current seat I is 12, which 12 is occupied. So it changes to L. What? Oh. Why was I looking at 12? It was already right. I need to be looking at... What is this? This should be, what, 19? Alright, let's try this again. First one, second one. Whoops. I needed to stop on that one. First one, second one. And then here, we need to stop on 19, right? This is 9, this is 10, this is 19. Let's stop at 18. All right, 18. This is where it currently is. So it has 4 adjacent. So it should turn to an L, right? Current seat of 18 is currently occupied. So we should see it change to not occupied for having 4 adjacent. So it says can write is false. That's not right. Can write. What am I doing? 18. 10 minus 18? Why am I doing this? Oh. Oh, I did it backwards. So this should be yes, I did make this a little bit more complicated than it needs to be. What does it look like? So step 2 looks more better. Or what is it, step 3? Yep, looks all correct. The last one looks right. So what do we get for an answer? 38. Ooh, 38. And the real answer is what, 37? Once people stop moving, you count 37 occupied seats. Why am I off by 1? Let's check this out. That's correct. That's correct. Right. 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 Ooh, this one right here is not right. That's my 1 off. So what is that? This is position 99. This is position 89. So 89. What am I doing here? I want something in here. 2. We want to stop on the second from last one. What's happening here? Okay. So we have 3 more after this. 1, 2. Is this our second from last one? Yes. So this one is the one I want to check. So we're at 89. And 89 should turn... Why are you already an L? Or a pound? When did you turn into a pound? This one should have turned to an L on the second step. One more. Okay. So we're at 10. And it's saying I can't go right, which is true, but it also says I can't go down, which is not true. So can't go down. What am I doing? 89 plus 10. It should be less than or less than the length. There we go. We got a solution. All right, let's yank out our prints. Let's get our puzzle input. Let's throw it into here. We'll run it. Index was out of range. Is it because of that extra line that I'm expecting? Let's see. 99 by 91. $9,008. Why? What? How can you be out of range? Let's see. So that's 8281 divided by lines count divided by 91. So lines. There's 91 of these. Oh. What? How did I do this correctly before then? Maybe it was this one that was wrong? 281 modulus 99. Index was out of range. Really? It should be position 91. Oh. Why am I off by 1? How the heck did I do the other one? In by 10. Maybe this needs to be what am I doing? Why are you giving me 91? This really is 91. Working with the race. Where's my problem? Here we go. Yeah, I didn't think so. What happened here? No, there's spaces on these. No, they look okay. Why is this parsing correctly, but... Oh, input. But this isn't for some reason. $91, each with a length of 99. Why are you incorrect? $99. Let's see, seats. I mean, it correctly applied 1 through 99, right? $99 should be right here. But you got a dot here instead. Why do you have a dot? Interesting. What is math floor? Why don't you just return an integer? What are we at? 82, 81. Yeah. I guess this should have been -1. Well, then all my other ones, yeah, I'm jacking this up because I didn't put in this floor one correctly. Now my answer is going to be incorrect. $81.90. Boy, am I going to have to rewrite all of this just to fix my index here? Oh, I'm already an hour and 20 minutes into this. I mean, it's a fairly simple problem. I just spent way too much time on getting this array stuff working. I should have just built a grid of like classes or something. Or just used a 2D array. I don't know why I didn't. Well, I guess I can now. Let's go 2D. X length, Y length. Draw this X. Make this a little more intuitive. That's a shame. But I might as well redo this now before I spend a ridiculous amount of time trying to figure this out. So see that position XY equals lines Y, position X. Let's see. So we need to change this to 2D. We need to change turn out X and Y. And once we get through, we'll give it another right line. And here, we change this into a 2D array. 2D, 2D, 2D. X-lang, Y-lang. Current seats, we need to change this to a double XY loop. Let's see if seed set XY, seed set XY. Get rid of that. Can left is x is greater than 0. Can right is x is less than x length. X length minus 1. Can up is y is greater than 0. And down, y is less than y length minus 1. If we can left, then x minus 1, y. If we can right, x plus 1, y. If we can up, it's x and y minus 1. Can down, it's x and y plus 1. Left, x minus 1. Up, y minus 1. Left, x minus 1. Down, y plus 1. Right, x plus 1. Y minus 1. And x plus 1, y plus 1. Can up, can down. All right. Y. X, Y. All right, we have all our, is that all of them? And the last thing we need to do is count. Count. Let's see. I guess we'll do another XY. Figuring out how to, instead of figuring out how to do this in Link. Total occupied. If seats XY equals pounds, then total occupied not all code paths return a value. Oh. Oh, I want to turn off the print. Where's the print? Print. All right, we get a number. Let's see if this guy works. We get 37. Okay, makes sense. What was the number for this one? 2354. Why do I keep losing my tab? Yeah, that's right. Of course it is. Okay. As soon as people start to arrive, you realize your mistake. People don't just care about the adjacencies, they care about the first seat they can see in each of those 8 directions. Okay. Now, instead of considering just 8 immediate adjacent seats, consider the first seat in each of those 8 directions. So how do we spin that? Leftmost, the first seat they can see in any of those 8 directions. Yeah, where do they start? Left? It takes 5 or more visible occupied seats for an occupied seat to become empty. Okay. They'll sit down if the first occupied seat they can see in each of those. They care about the first occupied seat. For example, the empty seat below would be 8 occupied seats. The leftmost empty seat below would see 1 empty seat, but cannot see any of the occupied ones. The empty seat below would see no occupied seats. The first seat to their left, ooh, I think I see. Oh, so in all directions diagonal, they'll count it if it's in any of those directions, to the left or to the right. Ooh, that's tricky. All right, let's get this guy. And we need to adjust our calculate next seat. We're going to call this one calculate next seat 2. All right. So we need, once we still have the same rules, but the seat is empty if there are no occupied seats. Takes 5 or more to become empty. Becomes occupied if there's no adjacent seats, but in this case, it becomes occupied so this one stays. Why would this one become occupied? The leftmost would only see one empty seat, but cannot see any of the occupied seats. Okay. So this one would flip, this one would not. So it's not... So I guess what we need to do is go to the left until we see while let's see. If the current seats is occupied, then num occupied, that's equals 1, and then break. Ooh. We need to both count the adjacent ones. So for the ones that are already occupied, we need to count adjacency. For the ones empty, we need to count first seen. So let's see. Count first seen. And we'll grab current seats, X and Y. Okay, so while we can move to the left, current seats, X, Y. Let's see, it's occupied. This needs to be temp-x. All right, that's a lot. We'll do the same thing except to the right. This is going to be a lot of code. Right. That's to the right. Now we need to go up. And we can go up if y is greater than 0. There's probably a much more elegant solution to this. This is certainly a lot of boilerplate nonsense. So to go up, we need to add to y. Right, and we're going to go down. And can go down. All right. We need to do 4 more of these. Can left and can up. Can left, can up. No. This needs to be temp again. Right. After left and up, it's left and down. So down is this guy. Now we go right and up. So we grab right. And we grab up. To go to the right, we add, go up, we subtract. And the last one is right and down. So we already have can right, we just need can down. And down is plus. Okay. So that one is count. Oh my jeez. Count per scene. We can move this into a count adjacent. So pretty much everything right here. And then, so let's see. So if we're a empty seat, we need to count per scene. Let's see, count per scene per seat 6y. If it's greater than, it needs to be 0, right? Else, if we're occupied, we need to count adjacent. And if that's greater than, what was it, 5, they said? 5 or more. So if it's 5 or more, then we'll turn it into a L. And we basically need to grab this guy again. And instead of calculate next seats, calculate next seats 2. Index out of range. Y and negative y. That's because this should be, all of these should be a do while. Do while. Do while. You gotta be careful not to mess this up. Index out of range. Oh. How should we do this? Plus 1, minus 1, plus 1. Also +1. Outside of range. Are you sure? 1 and -1. Yeah, that doesn't look right. We're at 1 and 1. If temp y minus 1 is less than why? How did we get here? Now, I guess we're doing a weird sort of for loop here. And let's put their boundaries in every single one of these. If I guess that's okay. Temp y. And these guys, so for the ones that we're going greater than 0, oh boy. Let's see, temp x needs to be greater than 0. Okay. You should be okay. Should be okay. This one should be canned down. This one should be can up. Oh yeah, I think I switched. I guess that's what you get when you have a crazy number of these things. Ten. Is that right for can down? Temp wise 10. What? Oh. It needs to be temp. So does this guy down here. Okay, geez. Uh-oh. Why did we get 37? Oh, you know what? We're reusing our seats. For solution 1. Let's see. Let's use seats 1 for you. What? Oh, maybe I can't clone it like that. How do we do a Darnell deep copy? Okay. Only single dimensional. Let's just copy it real quick. Why not? There we go. One deep copy. Uh-oh. Something's not right. So we got a copy, right? Seats 1. Oh. What happened here? Oh, there we go. Yeah, it looks okay. Ooh. Missed one. There we go. 45. Yeah, you're not right. Alright, how do we look? Start with this one. Yep. And we go to all occupied. Yep. And then we go to some goofy mess. So this one should stay occupied, right? This one... Oh. What I need to be doing when I'm printing this out... Where's my print function? I'm printing this out. I need to go from ooh, what are you doing? YYXX. Yeah. Oh. Okay. So let's look at these, see what's wrong. So this one, yeah, this one should have been changed to an L, but it didn't. It changes to an L if 5 are adjacent, right? Oh, maybe we're counting adjacency by the first scene thing? If that's the case, then we need to do this one, count first scene. Is that correct? No. This one still stayed occupied. So 1, 2, 3, 4. It should have counted the one to the left. So let's see, this is position 3. And we're looking at our second run through. So there's run through 1. There's 2. And now we want to stop here. And when we want to stop at 2, 0. Now we gotta go through all through Y. Whoops. Dang. Well, I guess we could do 2, 1. So this one, we should get a count of 1, 2, 3, 4, 5. But we didn't. We're at 2, 1. We're occupied. And we should have gotten a count first of 5. What are we at? 2, 2. 2, 2 is giving us 7 occupied. Which should have been 8. Which one wasn't counted? Let's take a look at this. This goes to the left. This goes to the right. Temp X, Temp X. This goes up, Temp Y. All right, let's get back to looking at 2, 2 again. So 2, 2, we should have every single one of these should get triggered. Because we have 1 in all directions. One of these is not playing nice, and it looks like it's left. So let's see, can left, x is greater than 0. Mm-hmm. All right, 2-2. All right, well, Timpex, so we're at 2. It should be greater or equal to 0. I got 35. That's not right. But how are we looking? So the first, once we got to this one, we didn't get the correct answer. This one should have turned empty. Because we're counting 1, 2, 3, 4? How's this 5? 1, 2, 3. There we go, 4. And then 5. So what is this? 0, 1, 2, 3, 4, 5, 6. So we want to investigate 0, 6. All right, skip to the next one. Come here. We want y0. Okay. So we should get, we're here, right? 1, 2, 3, 4, 5, 6. So we should get left, down, left, left and right. Let's see. We get left. This should be right. We got right. And this is up, right? Yeah. We should get nothing for up. No, this is down. Okay, we got 1 for down. We got left, right, and down. This one is up. We get nothing for that. This one is left and up. We should get nothing for this. This one is left and down. We should get something for this. We did. And this is right and up. We should get nothing for that. And this is right and down. this is the one we should get something. So we're checking position 7-1, which is a dot. Now we're checking 8-2, which is a dot, right? And then we didn't get something. So down and to the right, once we got to 8-2, 8 plus 1, 9 is less than 10 minus 1. So this should be equal to less than x length. That right? We're at 8-2. 9 is less than 9. That's not right. No, x length is 10. Yeah. And then 2. 3 is less than 9. Okay. Well, the one we checked is now correct, but now this one is not. And it's not correct, probably because of down and to the left. Because we've kind of validated bottom to the right. So we got 1, 2, 3, 4. And the fifth one is going to be down and to the left. So let's see. Down and to the left is this guy right here. So this should be greater than or equal to 0. Should these all be like this? Ooh, that's looking nice. Yeah. What do we got? We got 26? Okay. I think we actually got it. Yeah, this is just a big logic thing. We don't want to print all that. There we go. Yeah, I mean, there wasn't, I guess, anything particularly tricky about this one. Yeah, I still got a terrible time here. 2 hours to sludge through this. It's really like how logically or how reasonably you can iterate through this, 2D array. And the way I'm doing it is probably not. It can't be the right way because I'm sure people figured this out way faster. There's got to be a way more efficient way to search through and say like, hey, this is adjacent or that's adjacent. Yeah, how would I do this more efficiently? Because what I'm doing here is I'm taking my first state of seats and I'm sending it to this calculate guy. And it's going to go through every single seat. And once it gets to a seat, it's going to, check what it currently is. If it's a dot, it's just going to continue on. If it's empty, it's going to do this count for a scene. And basically, it's going to do all these, they're while loops, but essentially they're a for loop. So I'm going to, slowly go to the left, slowly go to the right, slowly go up, slowly go down, and check every single one. Yeah, I'm sure there's a much better way. And it might be, kind of like how I was doing that single dimensional array and then using, modulus to kind of figure out if I'm, up a level, down a level. The problem with that is that, it's a little tricky when it comes across to, you're doing division, making sure you're properly converting between, doubles and floats and integers. But yeah, there probably is something like, using modulus tricks to simply just walk through this. Well, that is the solution. I do have this, huge mess of code, but I guess it technically does it. Maybe this is a fine way of doing it, just, instead of having all this boilerplate code, I have some function that says, has neighbor or something. Okay, well, that's it for this one.